Hello, and now we are going to discuss about characteristics of groups. Earlier we discussed about periods. Now there is a sharp contrast here. In the case of periods, every time when you move across a period, the number of shells increases by 1, whereas I'm sorry, in the I'm sorry, in the period, when you move along a period, number of shells remain the same. Only thing, we add one electron to the valence shell or outermost shell. So in a period, we are when you move along a period, move across a period, we are adding one electron to the shell. In the case of groups, our number of shells increases by 1, whereas the number of valence electrons or the number of electrons in the outermost shell remains the same. Now here is a diagram of all the picture of all the periods and groups. There are 17 groups, 18 with the noble gases and 7 periods. Now we will study each group individually. Let us start with group 1, leaving the hydrogen apart because hydrogen can be placed into both group 1 as well as group 17, even though it has lot of properties similar to elements in group 1. Let us start with group 1 elements, starting with lithium. Lithium, sodium, potassium. The electronic configurations are 2,1, 2,8,1, 2,8,8,1. So you can see all these elements have one electron in the outermost valence shell. As I mentioned, we will not discuss about hydrogen here, even though it has properties similar to elements in group 1. Now the valence electrons, number of valence electrons, 1 for every element of group 1. That means they will be forming like lithium chloride, sodium chloride, potassium chloride. So they form single positively charged ion by donating one electron. That's why I wrote minus one electron, forming lithium ion, sodium ion and potassium ion. Let us look into group 2. Elements are like beryllium, magnesium, calcium. Electronic configurations are 2,2, 2,8,2, 2,8,8,2 and number of valence electrons 2. So and they form positively charged ion by donating 2 electrons, like beryllium ion B2 plus by donating 2 electrons, magnesium 2 plus like MgCl2, calcium chloride CaCl2. So they form positively charged ion having 2 positive charges by donating 2 electrons. Let us look into group 13, starting with boron. Boron, aluminium, germanium. Electronic configurations are 2,3, 2,8,3, 2,8,18,3 because we have transition elements here. You can see the elements here. Now as you see, the outermost shell is having 3 electrons. The number of valence electrons are 3. Of course, these elements are less electropositive compared to elements of group 1 and group 2. As we move from our group increases, the electropositive character decreases and electronegative character increases. Let us look into group 14, starting with carbon. Okay. Now all these elements have 4 valence electrons, but this valency will be covalency because their electropositivity is much reduced because it is in group 14. In group 1, electropositivity is the highest. Then let us look into group 15. You can see it here, starting with nitrogen, group 15. Their electropositivity is even less. In fact, their electronegativity is more prominent than electropositivity. And number of valence electrons are 5. As you know that with 5 valence electrons, it is easier to gain than to lose. It is very difficult to lose 5 electrons. So these elements, 14, 15, 16, 17 group elements, they are more electronegative. Let us look very carefully into group 17 elements called halogens. Fluorine, chlorine, bromine, iodine, astatine. I have not written astatine here. Electronic configurations are 2,7, 2,8,7, 2,8,18,7 2, 8, 18, 18, 7, and as you can see all have valence electrons, number of valence electrons as 7. But interesting thing is they form positive ions, they accept electrons, they accept one electron. So when they accept electrons they will have one extra negative charge, so they will form negative ion like fluoride, sodium fluoride, chloride like sodium chloride, potassium chloride, bromide, iodide ions, because they are electronegative elements. Group 17 elements are electronegative like group 16, like group 15, because as we move, as the group number becomes higher, their electropositivity decreases and electronegativity increases. So group 16, group 15, these elements are more electronegative, whereas group 1, group 2 elements are more electropositive. So lower groups are more electropositive, higher groups are more electronegative. This thing you should keep it in your mind. So this is about characteristics of groups, especially with respect to their valence electrons.